Good evening. Today I am going to take you through my project of fraud detection in credit card transactions. So, coming to the introduction. This problem involves the detection of credit card frauds. It is important to detect frauds in credit card transactions, and this is not a problem which can be detected by humans. As there is a lot of data, and we need to go through each of the data to understand the trends in the data and detect any anomalies. So in order to solve this problem, one of the best methods I've been using here is using machine learning. So I access the data set from Kaggle in this project, and I've done a lot of machine learning training to get results. So I took a data set from Kaggle and I've done statistical analysis of the data set. I observed that there was a heavy imbalance in the classes. So in this data set, there are out of the total 2,84,807 transactions. There were 492 fraud transactions. That is just 0.172% of the fraud transactions in the entire dataset. And the dataset also consisted of 28 features, that is from V1, V1, V2, V28 amount, and so on, which are the numerical information from a PCA transformation for confidentiality reasons. There are two columns, that is the time and amount. Considering that the time has no proper causality, I decided to drop this feature from the dataset. Performing the univariate analysis. Performing the univariate analysis shows the feature correlation with the class. Bivariate analysis showed the feature correlation among each other was very low. But I still decided to not drop any features, as even small information could be crucial in the model. Besides, we can see that the feature V17, which is highly correlated with class, and feature V22 is very low correlation. It has very low correlation. So by this, it analyzed me and helped me in the further steps of the project to decide from which feature the outliner points can be removed such that it does not have a proper higher impact on the prediction of classes. So here we can see that the correlation matrix of the dataset, it consists of 5 rows and 30 columns. I have shown some of the values in my project report, which is followed by the heat map. So in this heat map, it reflects the information as we see above, that the correlation between the features is very low. In this data set, there are a lot of outliners. We can see that there are a lot of outliners, and it can be seen in the box plot which is done for some of the features for class 0. Outliners are always not a bad thing. These points can still contain information which can be essential for the prediction processes. This box plot consists of feature V22, V23, V27 and V28 system. And we can see that after I pre-processed the dataset, so as the dataset contained 2,84,315 class 0 data points and 492 class 1 data points. Among these data points, I split the data into test data and train data. With that, the test data is being 30% of the entire data set. I got 1,99,019 class 0 and 341 class 1 data points. In the train data set and the rest is the test data set. So I will walk you through that. Yeah, we can see that I got 1,99,019 class 0 training data set and 345 class 1 training dataset, and the test datasets were 85,296 class 0 test datasets and 147 class 1 test datasets. So as we have seen that the dataset is extremely imbalanced. To handle such dataset, there are many methods. So I have chosen to downsample the majority classes, that is class 0 and the train models with the downsample datasets. I've done downsampling of the dataset in two different ways. One was I did not remove any data points from the train dataset I got from the test train split. I downsampled the class 0 data points randomly from the training dataset. The second method, I removed all the outliners such as features such as V22, V23, V25, V15, V26, V13, V amount, V24, V28 and V27. I have decided not to remove any other features of the datasets. For both the methods, the number of so here we can see. Yeah, I've decided to remove V22, V23, V25, V15, V26, V13, amount, V24, V28 and V27 features. For both the methods, the number of data points for class 0 was sampled such that they were 20 times greater than the class 1 data points. So the final two downsample dataset consisted of 6,900 class 0 data points and 341 class 1 data points. This is the class count of the dataset after I've downsampled it. So the process which I've used to detect the outliners is the interquartile range of detect, that is the IQR. So I've decided to remove the outliners because most of the machine learning algorithms are negatively impacted by the process. So the outliners were, so Q1, it's the 25th percentile, that is Q2 is the mean, Q3 is the 75th percentile. So the IQR is calculated by the difference of Q3 and Q1. So any points that was lying below the Q1 minus 1.5 times IQR and above Q3 plus 1.5 times IQR were called as outliers. So you can see that I have compared the feature distribution in a box plot before and after the removal of outliners. So this is before the removal of outliners and this was after the removal of outliners. So before the removal of outliners, we can see that the data set consists a lot of outliners. And upon removing the outliners, we can see the change in the box plot. So it is important to normalize and standardize the dataset. So the features are all similar scales. I use the robust scalar method to normalize the dataset because this method is resistant to outliners as the dataset consists of a lot of outliners. The robust scalar method works similar like the IQR method. So, and I view the machine learning models I've used for implementation are the KNN, the random forest, the decision tree, the logistic regression, the support vector machine. So I can run you through that. Three data sets were considered for training of the machine learning models. So the entire training data set that consisted of 1,99,019 class 0 and 345 class 1, and we've taken the downsample training data set consisting of outliners, which are 6,900 class 0 and 345 class 1, and the downsample training data sets not consisting of outliners, that are the same 6,900 class 0 and 345 class 1. And we've got the result here by implementing all the machine learning models. We can see that the AUC score and the TPR score is more when the model are trained with downsample datasets not consisting of outliners, but we can observe the FPR decreases. There is an increase in the FPR since the dataset is extremely imbalanced and the number of mispredictions are high in class 0. I observed that with respect to the AUC score, logistic regression model performed well. Also, the random forest has a good balance of TPR and FRP values. So, for the random forest model trained on the entire dataset compared to the trained on downsample dataset, the TPR value increased from 0.74 to 0.83, as we can see here. And FPR is at 0.99. And I've even plotted the ROC curve models for trained on complete dataset. We can see that the decision tree is not a good model and logistic regression is best among the four. So when I plotted the ROC curve for models trained on the downsample dataset containing outliners, we can still see that the decision tree is not is the worst model, and the logistic regression again remains the best model. So even for the ROC curves for models trained on downsample dataset not containing the outliners, still the decision tree is not that good, and we can see that the logistic regression is the best model. So here I can conclude that among all the models, logistic regression seemed to be the best model to find the fraud cases occurring while processing credit card transactions. From the obtained results, I was able to conclude that the dataset consists of information in outliner points. Accuracy is not a good metric to evaluate models that are trained on extreme imbalanced datasets. So using ensemble methods with proper weights will help with the prediction of classes better, because models trained on a downsample dataset can classify class 1 better and models trained on a complete dataset can classify class 0 better. So using an ensemble method will give better classification. Here comes to the final conclusion of my project. Thank you.